In this video, let us discuss some question and answers on the topic semiconductors. Distinguish semiconductors, insulators, and conductors based on band gap. Based on the size of the forbidden gap, the insulator, semiconductors, and the conductors are formed. The value of the forbidden gap for insulators is extremely high, that is more than 5 electron volt, while the forbidden energy gap is very small for semiconductors and no forbidden energy gap in the case of conductors. Explain the valence electrons and valence band. The electrons move in the atoms in a fixed energy levels, but the energy of the electrons in the innermost shell is higher than the outermost shell electrons. The electrons that are present in the outermost shell are called as valence electrons. These valence electrons, including a series of energy levels, form an energy band which is called as valence band. Define forbidden gap. The gap between the conduction band and the valence band is called as forbidden gap. As the name says, the forbidden gap does not have any energy and hence no electrons stay in this band. What is meant by Fermi level in semiconductors? Explain where does the Fermi level lies in an intrinsic semiconductor and an extrinsic semiconductor. The maximum energy that an electron in a semiconductor has at absolute zero temperature is called as Fermi level of energy. In an intrinsic semiconductor, the Fermi level lies in the middle of the conductor and the valence band, while in case of N-type extrinsic semiconductor, the Fermi level lies close to the conduction band, and for the P-type extrinsic semiconductor, it lies close to the valence band. Describe a hole and hole current in a semiconductor. When an energy is supplied to a semiconductor, the covalent bond breaks and the electron tends to move out of their place. The free electrons wander randomly and these free electrons create a space called as hole. The movement of hole, which is positively charged from the positive terminal to the negative terminal through the semiconductor, creates the hole current. Differentiate between intrinsic and extrinsic semiconductor. A semiconductor that is extremely in pure form is called as intrinsic semiconductor. Examples are silicon and germanium. An impure semiconductor that is formed by doping a pure semiconductor is called as extrinsic semiconductor. Describe the term doping and why it is needed. The process of adding impurities, that is trivalent or pentavalent, to the semiconductor material is known as doping. The conduction capability of an intrinsic semiconductor can be increased by adding some impurities. The doped intrinsic semiconductor can be called as an extrinsic semiconductor. Distinguish between P-type and N-type semiconductor. When a small amount of pentavalent impurity is added to a pure semiconductor, it gives N-type extrinsic semiconductor. And when small amount of trivalent impurity is added to a pure semiconductor, it gives P-type extrinsic semiconductor. What is meant by donor and acceptor impurities? If the outermost orbit consists of 5 valence electrons, it is called as pentavalent impurities, and this pentavalent atom donates 1 electron to the conduction band of the pure semiconductor atom. So it is known as donor atoms. While if the outermost orbit consists of 3 valence electrons, it is called as trivalent impurities, and this trivalent atom accepts 1 electron from the semiconductor atom. Hence, it is called as acceptor atom. Why silicon and germanium are the mainly used semiconductor materials. The energy required to break the covalent bond, that is, to release an electron from their valence band, is very small, that is 1.12 electron volt for silicon and 0.72 electron volt for germanium. Hence, the silicon and germanium are the mainly used semiconductor materials. Thank you for watching the video. For more details, please visit our website or mail to us.